Hi again, everybody. So we are going into section 1.5, and you'll see the problems in this section are almost exclusively about finding the equation of a line given some information. And we know that the equation of a line has this form: y equals mx plus b, where m is the slope and b denotes the y-intercept. More specifically, the y-intercept is the point 0, comma b. And we already know what the slope represents. If we take any 2 points on a line, it doesn't matter which points, the difference in the y-coordinates divided by the difference in the x-coordinates is going to be the slope. Okay. Now, in some of these problems, the slope will be given, or in some cases, we'll have to compute the slope. But as long as we are given the slope and a point, or if we're just given 2 points and that's it, that's really all we need to find the equation of a line. Okay, and we're going to put all these equations in this form. So let's say if we wanted to find the equation of a line with slope 4 passing through the point 2, 1, well, m, in this case, m is 4, and that means our equation is going to be of this form: y equals 4x plus b. Now and I'm going to write the b this way, because capital B, just because I don't want you to think that this is a 6. All right, so we'll just do it that way. Now there are a couple of ways we can find this b. The most straightforward way is plugging in the values of x and y in here and then solving for b. So in this case, x is 2 and y is 1. So we can substitute y equals 1 and x equals 2 plus b, and then 1 equals 8 plus b. Then subtract 8 from both sides, and so b will be -7. Okay, so it looks like that y is going to be 4x minus 7. And we can double check by plugging in x equals 1, we get, or x equals 2, we get 4 times 2, that's 8, 8 minus 7 is 1. So that works out. So that's the one way to do this, and maybe the direct way. Another way we could do this is we can write the equation of line in a slightly different form. We can write this as y minus the y-coordinate, and set it equal to our slope times x minus the x-coordinate. Okay, the x-coordinate is 2 in this case, right? So then what we have is, so we have y minus you always have a minus here, so it's y minus the y-coordinate equals our slope times x minus the x-coordinate. And then we simplify this. This will be y minus 1 equals 4x minus 8. And now in this case, we add 1 to both sides. And once again, we get y equals 4x minus 7. Okay? So that's one. There are a couple ways you can do this. This is going to be something called point slope form, but don't worry about that right now. For our next example, let's do it again. In this case, our slope is a fraction. It's -5/6. But we can do this exactly the same way. So we can write y equals -5/6 times x plus b. And once again, we can substitute in x equals 3 and y equals -2. So we'll get -2 equals -5/6 times 3 plus b. And okay, so how do we handle this fraction? We can think of this 3 as 3 over 1, and we can multiply the numerator and denominator, so this will be -15 over 6. All right, and let's not worry about simplifying this just yet. What we're going to do is add 15/6 to both sides. So we do that. We get 15/6 minus 2 is equal to b. And now we can get a common denominator. If we wanted to reduce this, we could, but we don't have to. We could just multiply and divide this 2 by 6. So this is 15/6 minus 2 times 6 is 12, so this will be 12/6. So b is 15 minus 12 is 3/6. And now we can reduce it to 1/2, right? So we get that y is equal to negative 5/6 x plus 1/2. Okay, and again we can check this by plugging in x equals 3. We get negative 15/6 plus 1/2. That'll be negative 15/6 plus 3/6. So that turns out to be negative 2. Okay. Next example, we have a little tricky one here. It's a line with slope 0. Now, as soon as we see it when the slope is 0, that means we're talking about a horizontal line. Okay. But we can still go, so we know that a horizontal line is given by y equals a number, and that number is just the y coordinate of any point on the line. And here, this point is on the horizontal line. The y coordinate is 4. So we know right away that y is equal to 4. So this is one of the degenerate cases here. Okay. But if you wanted to go through this again, you could also do it the way we did up here. You could write y equals 0x plus b. And then this 0x just goes away, and you get y equals b. And then you substitute y equals 4, and you get this. So you get the same thing. So after substitution, you get this. Okay. For problem example 4, this is a little bit different. We are going to we have to calculate the slope first, right? So our slope is going to be the change in the y coordinates divided by the change in x coordinates. So we have 9 minus 3 divided by 4 minus 2. So this is 6 over 2, which is 3. All right. And then we can, so our slope is 3. So our line in question is going to be in the form of y equals 3x plus b. And now we have the luxury of choosing either of these 2 points to plug in. I'll choose this one. So we'll let y equal 3 and x be 2. So we get 3 is 6 plus b, and you can check that b is equal to minus 3 when you subtract 6 from both sides. So I think we get y equals 3x minus 3. And we can double check this by plugging the values of the other point in. If we plug in x equals 4, we get 12 minus 3, that's 9. So this indeed is the right answer. Okay. Let's do another one. Another example where we have some negative numbers here. Same thing. We need to calculate the slope first. This will be negative 5 minus 5 over negative 3 minus negative 1. Okay, you have to be a little careful about with all these minuses here. This first minus comes from the fact that we're taking the difference in the x coordinates. And this minus 1 comes from the minus right here. All right, so negative 5 minus 5 is negative 10. And this is negative 3 plus 1. Negative 3 plus 1 is negative 2. So it looks like that this is 5. Okay, the negatives cancel out. And so our line is going to be y equals 5x plus b. And once again, we can we'll take the first point here. Y is 5, and x is negative 1. So 5 equals negative 5 plus b. You can add 5 to both sides, and you get that b is equal to 10. So it looks like y equals 5x plus 10 is our answer. We can check this. If we plug in -3 here, we get -15. -15 plus 10 is -5, which is great. So this works. All right. Now the last two examples have to do with parallel lines and perpendicular lines. And remember, in this first example, at first it doesn't seem like they give us a slope. They only give us 1 point, but in fact they are giving us a slope. They say this line is parallel to this line, and parallel lines, remember, have the same slope. So this means that their slope is going to be the same slope as this one, and the slope here, this is in y equals mx plus b, where m is 4 and b is -1. So the m is 4, so that will be the 4 on our line as well. So we can write y equals 4x plus b, and plug in x equals 6 and y equals 1. Okay, this is 1 equals 24 plus b, and subtract 24 from both sides, and you get -23 equals b. So y equals 4x minus 23 is our line in this case. And then finally, perpendicular lines. If two lines are perpendicular, their slopes are negative reciprocals of each other. So because it's perpendicular, that means our slope is the negative reciprocal of 4, which is -1/4. Okay. So we would write y equals -1/4 x plus b. All right. In this case, we again plug in x equals 6 and y equals 1. Okay, this is -6/4. Okay, and well, let's just reduce this to -3/2, because that's what it is. And then add 3/2 to both sides, so this will be 1 plus 3/2 equals b. So it looks like b is 5/2. Okay, and so our solution would be y equals -1/4 x plus 5/2. Okay, and again we can check one last time. We plug in the 6 here. You get -6/4. That's -3/2. -3/2 plus 5/2 is 2/2, which is 1. Okay. And all the problems in this assignment should look like these. So good luck, everybody.